Alright, so this is section 5.6 part 3. I initially made a few attempts at this video in July. Now it's almost Thanksgiving in November, and I just got around to watching the video and it just wasn't very good, so I decided I was going to do it again, and let's see how this goes. So the problems that we have left to do ultimately want us to find an area by finding a top curve and a bottom curve, and doing essentially what we did for most of the problems in this section. The big difference is that the functions that are given aren't given with an interval, in terms of I want to give you a specific interval to integrate over, and what I have to do for the problems between 23 and 30 is create my interval. Now, how I'm going to create my interval to integrate over is to find 2 points where the graphs of the functions intersect, and I'm going to use those two values of x as the values that I'm going to integrate over. So for each of the problems between 23 and 30, they're kind of a two-part problem. The first part is to find 2 points where the functions intersect. Let me start by doing that in problem 24. So I'm going to find out where these functions f of x and g of x intersect, and I find where two functions intersect simply by setting the functions equal to each other. So I'm going to set the f of x function equal to the g of x function in my first step of each of the problems in 23 through 30. Because there's a square, I have to set the problem equal to 0 and solve by factoring. So I minus 2 from both sides. That's going to give me 0 equals x squared minus 3x minus 4. I'm going to factor this into 0 equals x plus 1 times x minus 4. And then I'll set the x plus 1 equal to 0 and the x minus 4 equal to 0. For the x plus 1 equal to 0, I minus 1 from both sides and get x equal to negative 1 as one of the values of x where these two graphs are going to intersect. And when you set the x minus 4 equal to 0 and add 4 to both sides, you get x equal to 4 for the second point where the graphs are going to intersect. So what I'm going to eventually do, I'm going to integrate between negative 1 and 4, the top function minus the bottom function dx. What I'm going to need to do is, over the window between x equal to negative 1 and x equal to positive 4, figure out which of these is the top function and which is the bottom function. So I'm going to pull out my calculator and sketch a graph. I'm going to graph f of x equal to 2, and that's not a terribly hard graph to do. I can do it with or without my calculator. Ultimately, I'm going to do my calculator. But this right here, because it only has a number without a letter to the right of the equal sign, its graph is going to be a horizontal line that goes through 2 on the y-axis. So the graph of f of x equal to 2 looks something like that. And I'm only going to look at the portion of the graph that goes between x equal to negative 1 and x equal to 4. This is the graph of a parabola, and I can't predict as well what it's going to look like, but I don't really have to predict. I can get my calculator to do the graph for me perfectly. I can tell if I'm doing good algebra on the first step if, when I sketch my graph, the graphs intersect right at the edges of the window. So I'm going to graph f of x equal to 2 and g of x equal to x squared minus 3x minus 2 together on one coordinate system. I'm going to set my window to only have the values of x where the graphs intersect. So x equal negative 1 will be my minimum value. X max equal to 4 will be my maximum value. When I hit graph, the first thing I'm going to see is a graph of f of x equal to 2, which is a horizontal line. The second thing I'll see is the parabola. And if I've done my algebra correctly on the first part of this, the graphs are going to intersect right at the beginning and the end of my window, which they do here. So all I'm trying to accomplish when I do my graph is to figure out in the window which is the top function and which is the bottom function. And it's pretty clear to me that the horizontal line is the top function and the parabola is the bottom function. This is the area that I'm going to find. And we find areas like this by integrating. And I'm going to take the top function, 2, minus the bottom function, x squared minus 3x minus 2, and integrate those over the window -1 to 4. I can figure out what this area is on my calculator if I enter this function and do this integration. So let me do this real quickly. Let me clear out the functions that are in there and integrate the function 2 minus parentheses x squared minus 3x minus 2. Don't need the brackets because I'm not writing the dx. Graph this function. It's going to have x-intercepts at the edges of my windows just because that's how that works when you do this subtraction. And now I'm going second calc, integrate, lower limit -1, upper limit 4, and it tells me the area that I'm shooting for is 20.833333. So my goal, the area that's I'm trying to find by hand is 20.83 repeating square units. So now I need to take this bit of calculus and turn that into the number 20.83. And I'll do that by first clearing the parentheses, or the brackets and the parentheses, I guess just the parentheses. I have the integral from -1 to 4 of 2, and when I clear this parentheses, I get minus x squared plus 3x plus 2 dx, because the minus sign attaches to that, flips that, and flips that. I'm going to combine the 2's together and to get a 4, and that x squared, it may not help me so much that it doesn't have a number in front of it, so I'm going to put a 1 in front of that x squared. So that's the function that I'm going to integrate, -1x squared plus 3x plus 4 dx. And I integrate by adding 1 to the exponent and dividing by the new exponent. So this term right here, it's going to integrate to -1x cubed over 3. Bring down the plus sign. This has an exponent of 1. It's going to integrate to 3x squared over 2. And this 4 term is really 4x to the 0. So when I add 1 to its exponent and divide by its new exponent, I'll get 4x to the first over 1. Supposed to evaluate this from -1 to 4. And maybe I can clean that up. I can rewrite this as -1x cubed over 3 plus 3x squared over 2 plus 4x, evaluated it from -1 to 4. Now I'm going to do my 2 evaluations, separated by a minus sign. The first number I'm going to plug in is 4. I'm going to go -1 times 4 cubed over 3 plus 3 times 4 squared over 2 plus 4 times 4. I'm going to get a fraction answer for this. And in the next parentheses, I'm going to go -1 times -1 cubed over 3 plus 3 times -1 squared over 2 plus 4 times -1 and get a fraction for that. I'm going to subtract the 2 fractions and I'm going to get a decimal equivalent of 20.83. My answer should be a fraction. So now I'll yank out my calculator, get to the main screen. First computation, -1 parentheses 4 up arrow cubed divided by 3 plus 3 parentheses 4 squared divided by 2 plus 4 parentheses 4. That gives me 18.66. I'm going to math enter it. and I get 56 over 3 for my first computation. Bring down this minus sign, move on to the next parentheses. In the next parentheses, clear this out, I go -1 parentheses -1 up arrow 3 divided by 3 plus 3 parentheses -1 squared divided by 2 plus 4 parentheses -1, and math, enter, enter, and I get -13 over 6. So I have 56 over 3 minus -13 over 6. The double negative is going to turn positive. When I add these two together, I better get 20.83 because my goal is to find the area, and I already know the area is 20.83 as a decimal. I want a fraction answer ultimately. So let me finish this up by going 56 divided by 3 plus 13 divided by 6. I get exactly that 20.83, so I know I have a correct decimal answer. For my final answer, I'm going to math, enter, enter, and make it a fraction. The only answer that I really need to see for problem 24 is that the area is 125 over 6 square units. But there's a lot of algebra to get to that. So for each of the problems between 23 and 30, when you start your problem 23, the first thing you're going to do is set the functions equal to each other. When you set them equal to each other, you're going to get two values of x, and you're going to set those two values of x as your x min and x max in your window. You're going to graph the functions, figure out which is the top and which is the bottom function, and then integrate over that window of x's, the top function minus the bottom function, and get your answer. Of course, I'd probably check my answer on my calculator just to be safe. All right, so now we'll move on to 25 and 26. So first step in each one of these problems is to get the window I want to integrate over by setting the functions equal to each other. So for my 26, I'm going to set the function 25 minus x squared, which is the f of x function, equal to the g of x function 9. Ultimately, I want to solve by factoring because there's an x squared. I don't like to have negatives in front of my x squared, so I'm going to get the 0 on the left-hand side and the thing that needs to be factored on the right-hand side by minusing 25 and adding x squared to both sides. On the left side, when I minus 25 and x squared, I force the left side to come out to be 0. On the right side, 9 and 25 have opposite signs, so they're going to give me a -16. I bring down the x squared. I want to factor that right side. It's not written so nicely to factor, so I'm going to rewrite it with the x squared first and the -16 second. And then I'm going to factor it into x plus 4 times x minus 4. I'm going to set the x plus 4 and the x minus 4 equal to 0. This is going to give me x equal to -4 and x equal to 4. So ultimately, to get the area that I want, I'm going to integrate from -4 to 4, the top function minus the bottom function dx. So I'm going to graph this in my y1, that in my y2, set my x min and my x max to be -4 to 4, and I ultimately want the graphs to intersect right at the edges of my window, and I need to figure out what the top and the bottom function is. This function right here is a parabola, and I know that the standard window from -10 to 10 isn't going to be high enough in terms of my y max, and I'm going to have to play with my y max a little bit to see which function's more clearly on top. But let me get started here. Put my y equals, do 25 minus x squared for one of the functions, y1, 9 for the other function, set my viewing window from -4 to 4 on my x's, and then if I don't do anything to my y's, I don't think I'm going to be able to clearly see this parabola, but I will be able to see this. This is a line that's up at 9 on the y-axis. I'll see that because the y-max is 9. I won't see this because the graph is, the y's aren't high enough, the y-max isn't high enough to see this. But when I hit graph, there's the line. You can't see the parabola. In order to see the parabola, I think it's up higher. I'm going to make my y-max higher, And I'm not exactly sure how high to make my y max, but I'm just going to guess 50. Hit my graph button. There's the 25 minus x squared. There's the 9. That's perfect. So there's going to be some window playing in this section. If on the test you get stuck on a window, you can come up and ask me, and I'll set your window for you to make it obvious which is the top and which is the bottom function. So the functions intersect right at the edge of my viewing window, which is perfect. The parabola is the top function, which is the 25 minus x squared. The line is the bottom function. So for my problem here, I'm going to integrate top function, which is 25 minus x squared, minus the bottom function, which is 9. And because the bottom function is a monomial, it doesn't need to go in a separate parentheses, dx. Alright, so at this point, I can enter this on my calculator and find out the answer. So my goal is to find this area. So I go between -4 and 4. I have a line and a parabola that intersects something like that. My goal is to find this area, and the way we find this area on our calculator is we enter the top function minus the bottom function in my y1 and integrate it. So let me clear out the functions that are in there. They won't help me find this area. I'll go 25 minus x squared minus 9, graph it, and integrate it between -4 and 4 by going second calc, integrate, lower limit -4, upper limit 4, and I get 85.3333 for this shaded area. So my goal is to get an answer that has a decimal equivalent of 85.3, but I want the fraction version of it. So I'm going to integrate this function, and in order to integrate this function, I might combine these like terms. This 25 minus 9 gives me a 16. So I'm going to integrate from -4 to 4, -x squared plus 16 dx, and that's just combining that 25 and that minus 9 and writing the x squared first. Now I'm going to integrate by adding 1 to the exponent, dividing by the new exponent. I'll get -x cubed over 3. And this 16, if I wrote it with an x, it would be 16x to the 0. And when I integrate it, you're going to get 16x to the first over 1. And I want to evaluate between -4 and 4 with the goal of getting 85.33 as an answer. I'm going to rewrite this a little bit better before I shove the numbers in. I'm going to write -1x cubed over 3 plus 16x. Having the -1 in front of the x cubed will make it easier for me when I go to enter my numbers in. So now I need to enter 4 and -4 in. In the first parentheses, I'm going to go -1 times 4 cubed over 3 plus 16 times 4. And in the second parentheses, I'm going to go -1 times -4 cubed over 3 plus 16 times -4. Calculator work from this point. So first parentheses, get back to the main screen. I'm going to do -1 times 4 up arrow 3 divided by 3 plus 16 parentheses 4, and math, enter, enter. So I get 128 over 3 for the first computation. I'm going to bring the minus sign, and I'm going to do the second computation by going -1 times -4 up arrow 3 divided by 3 plus 16 times -4. And that gives me -42.666. Math, enter, enter, gives me -128 over 3. So I get 128 over 3 minus -128 over 3. The double negative is going to be plus, so it's going to be 128 over 3 plus 128 over 3. I'm going to add those on my calculator. That's going to give me the area in a decimal, and I'll math, enter, enter to make it a fraction. It better give me 85.3 because that's the area that I'm shooting for. So last step, 128 divided by 3 plus 128 divided by 3 equals, it's exactly that 85.33. I know my answer is right. Math, enter this. And the only answer that I'd need to see for problem 26 is the area that we need to find is 256 over 3 square units. All right, so now you need to take a crack at 25. You need to find the values of x that you need for your lower and upper limits on your integral sign by setting the functions equal to each other. Then you're going to need to graph. And on your function, a standard window is going to work just fine. The 9 in front of the x squared isn't as obnoxious as the 25 in my problem. That makes the standard negative 10 to 10 window work just fine for you. All right, just a few more problems left. So first step in problem 28 and your first step in your problem 27 is to find the values of x where the functions equal to each other by setting them equal. So I'm going to set 5x squared equal to 10x. Because there's an x squared, I'm going to set it equal to 0 and solve by factoring. So I'm going to go 5x squared minus 10x equal to 0 by minusing 10x from both sides. I need to solve this by factoring. There's a common factor, so the kind of factoring here is 1 parentheses common factor factoring. I'm going to pull out my common factor of 5x and be left with an x minus 2. And then I'm going to set each of the factors. I'm going to set the 5x equal to 0 and the x minus 2 equal to 0. When I set the 5x equal to 0, I divide both sides by 5. On the left side, the 5's cancel and I get an x. On the right side, I get a fraction with a 0 in the numerator, which is equal to 0. And when you set the x minus 2 equal to 0, you get x equal to 2. So now I'm going to graph the 5x squared function and the 10x function, and I'm going to make my window 0 to 2. The 5x squared function, the graph is going to be a parabola because of the x squared, and the 10x function is going to be a line. So I should be able to differentiate the functions real easy. And ultimately, I want to integrate from 0 to 2, the top minus the bottom function, dx. Now I'm going to figure out what the top and the bottom function are. I'm going to put my calculator back to a standard window in a second here. So I'm going to enter the 5x squared function in y1, the 10x function in y2, change my x's to go from 0 to 2 because those are the values of x's that I'm concerned with. And I'm going to change my y's back to the 10s just because I don't think I need a 50. And now it's first going to graph the parabola because I entered that first, then it's going to graph the line. Wow. And I don't think I could see it well enough. I can see right here they intersect right here at the point 0, 0. The parabola does something like this. The line does something like this. And it looks to me like the line is on top the whole way. In order to see better what's going on, I need to get my y's way up. And I'm not sure what my y's should be. So if I just did this, if I did second calc, typed enter on value, I want to find the y when x equal to 2. If I just type in 2, it tells me y needs to be 20. That tells me if I make my y max any higher than 20, I'm going to see a good picture. Let me make my y max 30 and graph these. So there's the parabola, there's the line, and they perfectly intersect right at the edges of my window, which they need to do. The line is on top, the parabola is on the bottom. So when I go to do my integration, I'm going to integrate the line first, which is 10x, minus the parabola second, which is 5x squared. I don't need an extra set of parentheses around the parabola equation because it's a monomial. So that's what I need to integrate. I add 1 to the exponent, divide by the new exponents. So for the first x, I'm going to get 10x squared over 2. And for the next one, I'm going to get minus 5x cubed over 3. I'm going to evaluate that from 0 to 2. I might as well simplify this to be 5x squared minus 5x cubed over 3. Evaluate it from 0 to 2. It would be nice if I knew my answer, or the answer that I'm shooting for. I'm trying to find this area. My calculator knows how to find this area just fine, so I'm going to enter this function on my calculator, find the area, then get back to my calculus, because I don't want to get a calculus answer and not know if it's right or wrong. So let me go ahead and enter this function, 10x minus 5x squared, clear out the other functions that are in there, graph it, don't really care so much about the window, and now I'm going to second calc integrate. Lower limit's going to be 0, upper limit's going to be 2, and the answer that I'm searching for is 6.6 repeating, and I'm going to get a decimal version of that. So hopefully you can see everything that I entered. Looks like I had bad glare on the window here. So I entered the function 10x minus 5x squared. I graphed it. I did second calc, integrate, lower limit 0, upper limit 2, and that gave me the 6.6 repeating. By hand, to get that answer, I did the top function minus the bottom function. I integrated by adding 1 to the exponent, divided by the new exponent, simplified that a little bit. Now I'm going to do my two computations, separated by a minus sign. The first computation is going to be 5 times 2 squared minus 5 times 2 cubed over 3. And the second computation is going to be 5 times 0 squared minus 5 times 0 cubed over 3. This one, because all the zeros, is ultimately going to turn into 0. I'll do that for you, but I know that that's the case. Let me get back to the main screen, do this first computation, 5 times 2 squared minus 5 times 2 cubed divided by 3, math, enter, enter, which is 20 over 3. It's also that 6.6 number that I got earlier. And then next computation, I'm going to do 5 times 0 squared minus 5 times 0 cubed over 3, which gives me this 0. So now I'm going to subtract these. I'm going to go 20 over 3 minus 0 minus 0, and I get exactly that 6.6 repeating number, which was my goal to match up to that decimal. My answer is going to be the fraction version of this, which is 20 over 3. So my answer to problem 28, the area that's I'm worried about here, is 20 over 3 square units. So this is number 28. All right, so you give 27 a go. I imagine the window that I have for my problem will be suitable for yours in terms of the y-maxes. If the y's go between -10 and 30, you'll probably get an adequate picture. All right, so 27's for you, and now we'll do 29 and 30, which is the last bit of new material for the semester. It's a tricky problem in some sense. Maybe it's so easy it's hard. So I'm going to first find the values of x that I need to integrate over by setting the f function equal to the g function. And this one might be so easy it's hard. The f function is 0, the g function is x squared minus 9. It's already set equal to 0, so I can find the values of x that I need by just factoring and setting the factors equal to 0. This gives me x equal to -3. This gives me x equal to 3. So now I'm going to have to integrate the top function minus the bottom function between -3 and 3. And I need to graph to figure out which is the top and which is the bottom function. The tricky thing about this is that this function, when you graph it, g of x or f of x equal to 0, that graph is going to be the x-axis. That is the equation of the x-axis. And then the x squared minus 9 function is going to be a parabola. So this graph right here is going to be a line, and worse yet, it's the x-axis. So I'm not going to see it when I graph it because the x-axis already appears. And this is going to be a parabola. Parabola. I think the window that I have is probably going to be overkill. When I go to set my window, I know my x's need to go between -3 and 3, And I think my y's at the 10s will be okay. Probably leaving the y's at the 30s wouldn't have hurt. So in for my y equals, I'm going to clear out anything that's in there, put y equals to 0 for the f function, and then x squared minus 9 for the g function. Have the window set. My graph should intersect right at the edges of the window, and my parabola looks, something like that, which is perfect. So I'm trying to find this area, and clearly the top function is the line. So when I go to do my by hand work, I'm going to integrate the top function, which is the line, which is f of x, minus the bottom function, g of x, which is a parabola, x squared minus 9 dx. The x squared minus 9, because it's after the minus sign and it's a binomial, needs to be in a parentheses. So this is going to be, if I simplify this, I'm going to integrate from negative 3 to 3, and then this is going to be 0 minus x squared plus 9 dx, which is the integral from negative 3 to 3 of minus x squared plus 9 dx. And this 9, I should think of it as 9x to the 0. I'm going to figure out what this area is by integrating this on my calculator. I'm going to enter this without the x to the 0 in my y1. Clear out the stuff that's in there. Integrate negative x squared plus 9. Graph it. Integrate from negative 3 to 3. And my goal is to get 36. Wow, I'm surprised at that answer. So my answer that I need to get for problem 30 is 36 square units. And I'm going to get that by integrating this function. To integrate this function, I'm going to add 1 to the exponent, divide by the new exponent. To integrate that 9x to 0, I'm going to add 1 to the exponent, divide by the new exponent. I need to evaluate between negative 3 and 3. Having a negative x cubed might mess me up on my calculator, so I'm going to change that to a negative 1x cubed over 3. And the second piece I'm going to write is just 9x. I'm going to evaluate from negative 3 to 3. I'm going to plug both numbers in, separate it by a minus sign. The first number that I plug in is going to be 3, so I'm going to go negative 1 times 3 cubed over 3 plus 9 times 3. And the second number I'm going to plug in is negative 3. I'm going to go negative 1 times negative 3 cubed over 3 plus 9 times negative 3. Do both those computations from my main screen. So back to the main screen. First computation, negative 1 parentheses 3 up arrow 3 divided by 3 plus 9 parentheses 3. I get 18. Bring down my minus sign, and then next parentheses, negative 1 parentheses negative 3 up arrow cubed divided by 3 plus 9 times negative 3. I get negative 18. So I have 18 minus negative 18. The double negative goes positive. That gives me 18 plus 18, and I can actually add that in my head. So the answer to problem 30, the only answer that I need to see is the area is 36 square units. Again, for all of these problems, you have to show the work that's required. The work that's required is the algebra to find where the functions intersect and the integration of the top function minus the bottom function. So give 29 a go, and then all we'll have left is the review for Chapter 5, which we'll do next. But there won't be any new material in the review.